Hello, thank you for watching BikeGremlin YouTube channel. This is third video in the series on hydraulic bicycle disc brakes, where I will explain the principle of bleeding bicycle brakes. Bleeding of bicycle brakes is basically used to complete two functions, two tasks. Sorry for the terms in English. First one is to remove the old brake fluid, whether it is DOT fluid, that is glycol alcohol based, or mineral hydraulic brake fluid, which is a sort of a mineral oil. One is used by SRAM and the company, and the other by Shimano, Magura and the others. They use oils, but the principle is the same. You need to have clean fluid that is fresh, with no water or dirt or air with it. And the second function, which I already a bit mentioned, is to remove any air. Now, first function is important for the hydraulic fluid functioning and not having a lowered boiling point, because water can easily evaporate, creating sort of a gas gap. And when there's a high content of water in the brake fluid, it will start to make bubbles at lower temperatures. So when you brake, even if your brakes are not very overheated, you will start to lose the feeling in your brake. With DOT fluids, they are hygroscopic, how to say it in English. They collect all the water, so they are susceptible to that and should be replaced at 1 or 2 year time intervals, also depending on the mileage and use and how much dirt is in the system. But also with mineral fluid, which does not collect water, water will stay usually near the pistons, because oil is lighter and will float over it. So we'll have the same thing, only the water will not be connected and sort of mixed with the brake fluid, but it will stay near the pistons. But also with mineral oil brakes, they should also be bled for dirt and oil. The other obvious reason is, of course, it gets dirty because some of the dirt gets past the brake piston seals and contaminates it, so that might lead to brake calipers not working properly, and so on. And the other big reason is why bleeding is done the way it's done is to avoid air. Air is already what happens, the same effect you get when water gets overheated, but with air it's instantly and always there when the brakes are cold. That is, air gets compressed. Mineral and DOT brake fluids don't get compressed nearly as much when pressure is exerted, so all the brake force is sent to the brake pads through the system. But when there's oil, when there's gas, that is not the case. Gas gets compressed, you will not put enough force to make it liquid, and you don't have enough travel of the brake lever. You will just compress it, and then when you release it, it decompresses back. This is not very airtight that I could do with my finger, but that is the principle. It will act like sort of a bungee or a spring, making all the effort you put into the lever compress air, then decompress it without putting too much force on the brake pads, which is bad. That's why you get the poor performance. Brakes are practically not working. The same as happens when the water is boiled. Now with air, it is lighter than water and lighter than brake fluids, so it always goes up. You can see here a small air pocket that I have. If I put this upside down, it will be here. So in order to bleed the brakes, the whole philosophy and the whole principle is done so that you do not push any more air bubbles into the system while pushing the air bubbles that are already in the system out. Now how is this done? Well, with this example, the obvious choice would be to just make this opening be on top and then start pressing on the syringe. Okay, now you can see the air bubbles going out with a bit of oil, and that's it. Now there is no more air in this system. Once there is no more air, I can turn this around. There will be no air bubbles, nothing, which is what you want to achieve with your hydraulic disc brakes when you are bleeding. For that reason, hydraulic disc brake systems usually have two, how to say it, openings. One is at the lever and the other is at the caliper side. This one is old caliper, but will make it nice and work fine. Okay, so when you are bleeding systems, you want both of these to be upwards so that any air that is trapped can be pushed out. So like with this syringe, when I'm pushing new hydraulic fluid either through this, it will come through the caliper, pushing all the air out, and the bubbles are going out this way. Likewise, when I'm doing some lever pumping with these open types or using a syringe, if it is just one bleeding nipple there, I will be doing the same thing but vice versa. Many hydraulic brake systems, with many it's good to, once there's no more air bubbles coming out, to do a reverse procedure to make sure that any air bubbles that are trapped in this part that could not be pushed out by fluid going one way are pushed out by the fluid going in the opposite direction. So that is the principle, and that is the same reason why tapping the components is good, so that, and a bit wiggling them so that any air bubbles that might have been stuck get unstuck and bled. And once that procedure is done and the oil level is made to be flush with the seal so that no air bubbles can get again trapped in this system, you're all set and the bleeding process is complete. And now we will use these old hydraulic disc brakes to demonstrate that procedure. And I hope I've explained properly principle. If you have any questions, use the comment section. My English is not very good, but we'll manage. Thank you for watching. Cheers.